SpaceX CRS-7. Alright, let's dive into the story of SpaceX CRS-7, a mission that started with high hopes and ended in one of those "oh no" moments you can't forget. Picture this. It's June 28, 2015. The Falcon 9 rocket sits on the launch pad, gleaming under the Florida sun, ready to take cargo to the International Space Station. It wasn't just any delivery. This one carried food, scientific experiments, and even a docking adapter crucial for future crewed missions. You know, like Amazon's same-day delivery, but with science and space adventure vibes. Then, the countdown hits 0. Engines roar. Off it goes, streaking skyward. Everything looks perfect. At first. But then, a little over 2 minutes into the flight, something shocking happened. Out of nowhere, the rocket just disintegrated midair. Boom! Debris scattered across the sky and millions of dollars worth of cargo and equipment were reduced to nothing more than a cloud of fragments raining down into the Atlantic. For a brief moment, it seemed like no one even understood what went wrong. It was almost as if someone hit the self-destruct button, but trust me, no one wanted this outcome. Now, here comes the surprising part. When SpaceX investigated what caused this very public failure, the culprit turned out to be a single metal strut. Yeah, a strut. This little piece was supposed to hold down a helium tank inside the rocket's second stage. During the ascent, the strut snapped under the force, sending the helium tank shooting up like a spring-loaded toy escaping a box. This sudden movement caused a massive pressure spike in the liquid oxygen tank, leading to what experts politely call a rapid unscheduled disassembly, or in normal terms, everything blew up. But what makes this even more of a wild ride is how SpaceX reacted. Instead of blaming bad luck, they owned it. They dug into every detail to make sure a single strut never again spelled doom for their missions. It's a testament to how in the unforgiving world of space travel, even the tiniest component can lead to a catastrophe, and how every failure holds a lesson to push the boundaries of human achievement. So, the next time you see a rocket launch, remember, sometimes it's not the flashy engines or fiery boosters that decide success, but the humble little pieces you'd never notice until they fail. Apollo 1. On January 27, 1967, during a pre-launch test, 3 astronauts, Gus Grissom, Ed White, and Roger B. Chaffee, were trapped inside their spacecraft when a fire erupted. The Apollo capsule, which was supposed to take astronauts to the moon, was sealed shut during the test in a pure oxygen environment. A spark from faulty wiring ignited the oxygen, and within seconds the cabin was engulfed in flames. Tragically, the crew couldn't escape, and they died in the instant heat, still trapped inside their seats. The aftermath of Apollo 1 was a painful and humbling moment for NASA. The entire space program came to a screeching halt as the investigation into the fire unfolded. It turned out that a combination of design flaws, poor materials, and a failure to address potential risks led to the disaster. The cabin was made from highly flammable materials, and in the pure oxygen atmosphere, even the smallest spark could set off a catastrophic fire. What made this event even more tragic was that the astronauts were on the verge of a major milestone, launching the first crewed mission for the Apollo program, aimed at sending astronauts to the moon. The fire effectively grounded the entire space program for months as NASA had to completely reassess its approach to safety. Now, here's the shocking part. The Apollo capsule designed to carry astronauts into space was riddled with fire hazards. The cabin was lined with flammable materials like Velcro and plastic insulation, which in the oxygen-rich atmosphere became highly combustible. And let's not forget about the hatch. The capsule's hatch was designed to open inward, which would have made it nearly impossible to open during an emergency with the pressure inside. It was a series of poor decisions from the choice of materials to the cabin's design that led to a tragic loss of life. It's almost hard to believe that this kind of oversight could happen when we consider the complexity and prestige of NASA's space program. The crew was essentially sitting in a fire trap, and no one realized just how dangerous it was until it was too late. But the heart of this story, as tragic as it is, lies in the aftermath. The lessons learned from Apollo 1 changed NASA forever. The space program had to completely overhaul its approach to safety. They redesigned the Apollo capsule to include fire-resistant materials and made improvements to the hatch, so it could be opened from the inside during an emergency. NASA also began to take a much more proactive approach in identifying risks before they could cause harm. It was clear that the astronauts' deaths could not be in vain, and that meant doing everything in their power to make sure such a disaster never happened again. Atlantis. Now, let's jump to 1983, a time when the space shuttle program was picking up momentum. Atlantis, the fourth shuttle in NASA's fleet, was ready for its second flight in November of that year. The mission's main goal was to deploy a satellite and test new scientific equipment. However, what was meant to be another routine mission quickly turned into a terrifying near miss. During ascent, a piece of foam insulation from the external fuel tank detached and struck one of the shuttle's solid rocket boosters. The foam caused a small crack in one of the shuttle's heat tiles, a critical component to protecting the vehicle during re-entry. If the damage had been more severe, Atlantis could have suffered a fate similar to Columbia's years later. Miraculously, the mission was completed successfully and the shuttle returned to Earth safely, but the danger was very real. What makes this incident shocking is that it was a clear indication that NASA was still grappling with the same risks that led to the Challenger disaster. The foam insulation problem that caused the Challenger explosion had been known, but it hadn't been addressed thoroughly. After Atlantis' close call, NASA realized that even the smallest damage to the shuttle could have catastrophic consequences. This near disaster led to a re-evaluation of the shuttle's external tank design, with improvements made to prevent foam shedding. While Atlantis did survive this mission, the close call was a stark reminder of the fine line between success and failure in space exploration. Orbital Science's Antares. Okay, let's rewind the clock to October 28, 2014. It was a typical evening at the Wallops Flight Facility in Virginia, and all eyes were on Orbital Science's Antares rocket. It stood proudly on the launch pad, loaded with supplies for the International Space Station, food, scientific equipment, you name it. This wasn't some throwaway mission. It was a big deal. Everything seemed to be going smoothly. You know how it goes. Countdown ticking, ground control tense but hopeful, and the roar of the engines marking liftoff. Antares soared into the sky for a whopping 6 seconds. Then, disaster struck. Right before everyone's eyes, the rocket faltered, hesitated, and then, boom! The explosion turned night into day, lighting up the sky in a fiery spectacle of destruction. The ground shook, spectators gasped, and debris rained down in every direction. In those few harrowing moments, a multi-million-dollar space mission was gone. The sight of Antares exploding is seared into memory, like one of those moments you can't believe is real until the dust and the shock settles. So, what went wrong? The investigation revealed something unexpected, almost ironic if it weren't so serious. The failure was traced back to the AJ-26 engines, which were actually modified Soviet-era engines from the 1960s. Yep, you heard that right. Decades-old engines were given a facelift and repurposed for modern missions. Sounds like a cool retro comeback, right? Except, in this case, it was more like using Grandpa's hand-me-down to win a race. One of those engines had a turbo pump failure, which caused a catastrophic chain reaction. Long story short, it was like giving your old clunker a shiny new paint job and hoping it would drive like a sports car. Spoiler, it didn't. But here's where things get even more intriguing. Orbital Sciences took a hard look in the mirror and made some big changes. They ditched the aging Soviet engines and switched to modern, more reliable ones for future missions. It was a wake-up call, not just for them, but for everyone in the space industry. In the high-stakes world of rocket science, cutting corners or relying on nostalgia can lead to literal explosive results. It's a powerful reminder that even a small, weak link, like an outdated engine, can bring down something meant to touch the stars. Challenger disaster. On January 28, 1986, the world watched in horror as the Space Shuttle Challenger, just 73 seconds after liftoff, exploded in a massive fireball. 7 astronauts lost their lives that day, including Krista McAuliffe, a high school teacher who was selected to be the first civilian in space. The crew was meant to demonstrate the shuttle's capabilities in a routine mission, but what they didn't know was that the O-rings, the seals meant to protect the shuttle's solid rocket boosters, had been compromised by the cold weather on launch day. The cold made the rubber seals brittle, allowing hot gas to escape, which led to the shuttle's deconstruction. The aftermath of Challenger was devastating, not just for the families of the crew, but for the entire space program. NASA's reputation took a major hit. The Rogers Commission set up to investigate the disaster, uncover a tragic truth. Engineers at Morton Thinkall, the company responsible for the boosters, had warned about the O-rings in cold temperatures, but were ignored by NASA's officials. This failure in communication and oversight was a huge blow, revealing that the drive to keep to a strict launch schedule took precedence over safety concerns. The U.S. space program was grounded while improvements were made to the shuttle's design, and NASA's safety culture was thoroughly overhauled. The Challenger tragedy reminded everyone of the human cost of space exploration. making it clear that space was not the final frontier, but a dangerous and unforgiving place. The lessons from Challenger were painful but necessary. NASA had to confront the ugly truth. Their pursuit of progress had pushed safety to the side. The shuttle program was grounded for nearly 3 years, and in the wake of the disaster, NASA made sweeping changes to their safety protocols. The idea of cutting corners for the sake of time or political pressure was no longer acceptable. In the end, the Challenger disaster didn't just cost 7 lives, it forced NASA, the entire space industry, to reevaluate how space exploration should balance ambition with the unavoidable risks of human life. Apollo 13. Apollo 13 was supposed to be the 3rd mission to land on the moon, but just 56 hours into the flight, disaster struck. An oxygen tank exploded, causing a massive loss of power and threatening the lives of astronauts James Lovell, Fred Heiss, and Jack Swigert. The explosion crippled the spacecraft, forcing the crew to abort the mission and make a harrowing journey back to Earth with limited power, water, and no direct way to communicate with NASA. But here's where things get mind-blowing. Despite the near-catastrophic damage, the Apollo 13 crew and the team at Mission Control, now facing an unimaginable crisis, turned an almost certain tragedy into a story of survival, resilience, and teamwork. When the explosion occurred, it not only destroyed one of the oxygen tanks, but also led to the loss of critical systems, including the spacecraft's primary power supply. This meant that the crew had to rely on backup systems for life support, which were never designed to handle such an emergency. On top of that, the explosion damaged the spacecraft's guidance systems, leaving them with no way to calculate their exact location. Talk about a nightmare scenario. Now, let's talk about that famous line, "Houston, we have a problem." While it's often quoted, it's not entirely accurate. In reality, astronaut Jack Swigert's original words were, "Okay, Houston, we've had a problem here." But you get the idea. Things were going south, fast. The truth is, the mission wasn't just in jeopardy because of the explosion, but because every piece of equipment was meant for a mission to the moon, not for an emergency survival scenario. For example, the spacecraft was designed to be a one-way trip to the moon, so the return flight had no backup plan for power or life support systems. Essentially, the astronauts and engineers were improvising on the fly, using whatever resources they had on board to get them home. Soyuz 11. While Apollo 1 was the first major tragedy for the US space program, the Soviet Union had its own heartbreaking disaster in 1971. Soyuz 11. On June 30, 1971, 3 cosmonauts, Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov, were aboard Soyuz 11 on their way to the Salyut 1 space station. Their mission was to stay aboard the station for an extended period, conducting experiments in space, but things went terribly wrong during their return to Earth. As Soyuz 11 re-entered the atmosphere, a valve in the spacecraft malfunctioned, causing the cabin to depressurize. Without any air to breathe, the 3 cosmonauts suffocated before they could make it back to the ground. The shocking part? This wasn't some freak accident. Soyuz 11 had been under design review for several years, and there had been warnings about the spacecraft's vulnerability during re-entry. In fact, it was a well-known fact among Soviet engineers that the depressurization problem could lead to disaster. Yet, the decision to send the crew into space was made anyway, despite the flaws in the spacecraft's design. What's even more chilling is that the crew didn't know their lives were at risk until it was too late. When the cosmonauts failed to make contact with Earth after re-entry, search teams were sent out, and their bodies were found still trapped into their seats, a grim sight that highlighted the perils of space exploration. The aftermath of Soyuz 11's disaster forced the Soviet space program to take immediate action. They grounded the Soyuz spacecraft for an entire year, completely overhauling its design to fix the depressurization issue. But the damage wasn't just technical, it was cultural. The Soviet space program was known for its secrecy and its harsh approach to astronaut safety. The public didn't know just how close they had come to losing more cosmonauts, or how risky space travel was until Soyuz 11. The tragedy became a stark reminder that even in the race for space dominance, human lives couldn't be sacrificed for the sake of progress. Space Shuttle Columbia. Space Shuttle Columbia disaster took place on February 1, 2003. The shuttle had just completed a successful 16-day mission, but during launch, a piece of foam insulation had detached from the external fuel tank and struck the left wing of the orbiter. This seemingly minor damage, which went unnoticed at the time, turned catastrophic when Columbia re-entered Earth's atmosphere. The heat from re-entry breached the wing, causing the shuttle to break apart mid-flight, killing all 7 crew members aboard, including Ilan Ramon, the first Israeli astronaut. What makes Columbia's disaster even more shocking is how it happened so quietly and so quickly. The foam strike didn't immediately raise alarms because the damage seemed insignificant. However, when the shuttle hit the atmosphere at such high speeds, the small piece of foam had turned into a ticking time bomb. The aftermath of the Columbia disaster was profound, leading to another grounding of the Space Shuttle fleet and a comprehensive investigation into NASA's practices. Like Challenger, Columbia exposed flaws in NASA's safety culture, particularly in its communication and risk assessment. In the end, NASA had to rebuild trust with the public and its astronauts. It wasn't just a technological failure. It was a reminder of the personal toll space exploration can take. These space mission disasters from Challenger to Columbia remind us of the immense dangers astronauts face when venturing into space. They weren't just accidents, they were lessons in the fragility of human life and the unforgiving nature of space itself. And while we've made tremendous advances in technology and safety since these disasters, the sacrifices made by those who risked everything still echo throughout the space exploration community. Every mission is a reminder that space is a realm that doesn't forgive mistakes, and that's what makes those who venture into it so extraordinary. Soyuz 1. On April 24, 1967, cosmonaut Vladimir Komarov was piloting Soyuz 1 when a series of malfunctions led to a fatal crash during re-entry. The primary issue was a malfunctioning parachute system that failed to deploy properly after the spacecraft descended back to Earth. The parachutes were supposed to slow the spacecraft down, but only one of them deployed, and the landing gear failed. The result? A brutal crash landing that killed Komarov on impact. It's haunting to think that Komarov was aware of the spacecraft's flaws before he even boarded, but he chose to fly anyway, knowing it was a dangerous mission. His story is one of the most tragic examples of heroism mixed with tragic foresight. Komarov's fate was sealed when the moment he entered the Soyuz 1. It was actually a culmination of multiple issues. The spacecraft, which wasn't supposed to be a stepping stone for future Soviet space missions, had been plagued by design flaws and rushed production schedules. The parachute system, which should have been a reliable safety measure, was fundamentally compromised. Engineers knew about the issues, but couldn't resolve them in time for the mission. The space program, under intense pressure to show progress, pushed ahead with the launch despite warnings from Komarov himself. In fact, he had even expressed concern about the spacecraft's condition before takeoff, and sources close to him reported that he even told his colleagues that he might not return from this mission. Yet, driven by his sense of duty to his country and a belief in the importance of space exploration, Komarov chose to proceed. The haunting part? He knew this could be his last flight. The fallout from Soyuz 1 was immense. The Soviets were forced to take a hard look at their space program's safety protocols, and many of the issues with Soyuz 1 led to delays in subsequent missions. In the wake of the disaster, the Soviet Union had to confront not only the loss of a dedicated cosmonaut, but also a significant embarrassment to their space ambitions. The tragic death of Komarov led to extensive redesigns and improvements in spacecraft technology. Most importantly, there was a major overhaul of the parachute and landing systems, which had failed so disastrously during Soyuz 1's return to Earth. Soyuz 1 became a symbol of what happens when space exploration is driven by a sense of urgency and pride rather than safety and thoroughness. The Soviets were left to pick up the pieces, both literally and figuratively. What's particularly eerie about this disaster is that Komarov had been warned about the spacecraft's shortcoming, yet still decided to fly. Driven by his sense of duty to his country, his death was a grim reminder of how space exploration is often a one-way ticket if things go wrong, and that, no matter the program, the risks are always present. But Komarov's bravery also highlighted something essential about human nature: the willingness to risk it all for the sake of something greater, even when the odds seem stacked against you. In hindsight, his decision to fly in a spacecraft he knew to be unsafe seems almost incomprehensible, but it speaks to the commitment and courage that characterize many space pioneers. His story isn't just about the tragedy, it's about the spirit of exploration and sacrifice that defines the history of human spaceflight. Ariane 5. On June 4, 1996, just 37 seconds after launch, the rocket self-destructed, sending its payload of satellites plummeting back to Earth. The cause of the explosion? A failure in the rocket's guidance system. The computer system, which was meant to handle navigation, attempted to convert a 64-bit floating point number into a 16-bit signed integer. The system couldn't process this conversion, causing a failure that led to the deconstruction of the rocket. It's surprising to think that such a small technical glitch, something as trivial as a number conversion, could lead to the destruction of an entire mission, especially given the amount of testing that goes into space technology. It's like building an incredibly complex machine, testing it for months, and then discovering that one tiny programming error can bring it all crashing down. The whole disaster was a perfect storm of unforeseen issues. The Ariane 5 rocket was based on the earlier Ariane 4, a design that had proven to be reliable and successful. The thinking was that if it wasn't broke, don't fix it. But that's where the problems began. While the hardware was derived from the older rocket, the software that controlled the guidance system was an adaptation, and it had never been tested in the exact configuration of the Ariane 5. In a sense, the software wasn't prepared to handle the massive power and different parameters of the new rocket. It's a bit like trying to run a car engine with a navigation system built for a bicycle. Different, but not something you'd immediately think would cause a massive crash. And that's exactly what happened. The new rocket's higher velocity and payload stressed the old software in ways no one had foreseen. Ariane 5's failure was particularly notable because of the reputation it had before the launch. The Ariane 5 program had a solid track record, and Ariane 4 in particular was known for its reliability. So, there was a lot of trust that the new Ariane 5 would continue the legacy. But in the world of space exploration, no amount of past success is a guarantee. This failure wasn't just a technical glitch. It was a significant setback for the European Space Agency. No human lives were lost, which was a small mercy, but the mission carried a heavy financial blow: the loss of valuable payloads, including telecommunications satellites that were worth hundreds of millions of dollars. The aftermath of the Ariane 5 disaster was not just about salvaging reputation. It also prompted major changes in how the European Space Agency approached software testing and system reliability. ESA learned the hard way that assumptions about compatibility and software readiness can't be taken for granted. They overhauled their testing protocols, placing more emphasis ensuring that every component of the rocket, from the hardware to the software, was rigorously vetted for the specific mission parameters.